Hopefully you're okay with a basic titration question, a nice straightforward one where they give you a concentration and a volume, work out the number of moles, do the ratio, work out the concentration at the other end. Make sure you're confident with that, because that's the fundamentals of all titration calculations. But there's plenty of things they can make you do before or afterwards to make these questions a bit tougher. And this is just one example. These questions can get quite wordy, so it's important to read the question carefully. So we've got a titration to find the concentration of hydrochloric acid. Nothing new there. And they've given us 5.93 grams of calcium hydroxide weighed out, dissolved in water, and then made up accurately to make 400 centimeters cubed. As soon as you see that, you should be thinking, we've got a known mass of a chemical, we've got a known volume, they've just made a standard solution. What calculations do you know about standard solutions? Now, we've taken 25 centimeter cube portions. This was then prepared into a conical flask and titrated against the acid. The volume of the acid needed for neutralization is shown in the table below. Calculate the concentration of the acid. There's a lot going on here. There's a lot of different volumes for a start. So there's a couple of things we need to do to make things simple, to try and sort stuff out in our minds. First of all, we know it's a titration, so let's just write down what equations we're going to use. Because it's titration, number of moles is concentration times volume. But we've also got that mass and making a standard solution. So we also know that number of moles is mass divided by molar mass as well. They also haven't given us the balanced chemical equation, so we might as well write that down. We've got calcium hydroxide, and we're going to react it with some hydrochloric acid. And we're going to make calcium chloride and water. And then we can balance this as well. So we know that in any acid-base reaction, we need 1 OH minus for every H plus. Calcium hydroxide has 2 OH minuses, so we're going to need 2 of the HCl's to get 2 H pluses, and we're going to produce 2 waters. So now we've got a balanced equation. And also, because I always think it helps, let's have a quick diagram as well. So we have got a lump of calcium hydroxide here. And we know that weighs 5.93 grams. I'm going to dissolve it in a beaker. And then we're going to transfer that into a 400 centimeter cubed volumetric flask. So this is still going to be calcium hydroxide solution. And we know the volume equals 400 centimeters cubed. And then we're going to take from our volumetric flask 25 centimeters cubed portions. So we've still got calcium hydroxide in the conical flask, but this time our volume is only 25 centimeters cubed. And we're going to titrate that against HCl. Right, so there's a lot going on. So to keep things more organized, let's highlight what we know about the calcium hydroxide. So everything to do with the calcium hydroxide we're going to do in yellow. We've got the mass. We know we made it up to 400 centimeters cubed. We know that 25 centimeters cubed are the portions of that we've got as well. And then the hydrochloric acid, the only data we've got is this table. So there's a few different places we could start. But I think we might as well do it in the order the question says. Let's start off with the calcium hydroxide. So we know the mass, but mass doesn't really help us. We want to know the moles of calcium hydroxide. So to work out the moles of the calcium hydroxide, it's going to be mass divided by molar mass. So we know the mass is 5.93 grams, and the molar mass of calcium hydroxide is 74.1. So it's going to be the mass of calcium plus 2 times the mass of hydroxide ion. And that means we've got 0.08 moles. So that's how many moles we've got in our solution. So let's actually add that to our diagram. Because just because you draw a diagram to help you know what's going on, you might as well add the other information we've got onto it. Now, you could, if you wanted to, work out the concentration of your standard solution, but we don't actually need to. Because in any kind of reaction, we want the number of moles. We've already got the number of moles. So what can we do with that? Well, this 0.08 moles is in 400 centimeters cubed. But we take out 25 centimeters cubed of that. So we want to go from 400 to 25. Now, to do that conversion, all you do is divide by what you're going from and multiply by what you're going to. So with this 0.8, we have to divide it by what we're going from, so the 400, and times it by what we're going to. So if you do 0.08 and you times it by 25 divided by 400, that will give you the scale factor. Normally you do it with 250 and 25, but technically 25 divided by 250 is the same as just dividing by 10. So this is just a slightly more complicated version of that. So you end up 0.0050 moles in 25 centimeters cubed. So now we can add that to our diagram as well. So in our conical flask, our number of moles is 0.005. Right, now we're getting somewhere. If we know the number of moles in the conical flask, we can use the balanced chemical equation to work out the number of moles in the burette. Because it's the burette in the conical flask, that's where the chemical reaction we wrote down at the start is happening. So we need to work out the moles for when we get to that chemical reaction. And now we've got the moles at one side of this chemical reaction. So we can do the ratio of the calcium hydroxide, because that's the chemical we know the moles of, to HCl, because that's what we're trying to find out. And it's a 1:2 ratio, because we've got 1 mole of calcium hydroxide, 2 moles of HCl. So the moles of HCl is going to be 0.005, the moles of calcium hydroxide, multiplied by 2, which gives you 0.01 moles. So again, add it onto your diagram that you've already drawn. Number of moles equals 0.01. So we've now got our first bit of information about the hydrochloric acid. The concentration is number of moles divided by volume. We don't know the volume, but hang on a second. Yes, we do, because we've got this table of results. So whenever you're doing a titration, you always record your results in a table that looks like this, with initial reading, final reading, and you can calculate the titer. So the titer is just going to be the final reading, take away the initial reading. So 15 take away 1 is 14, but you'll never write down 14. Everything in this table will be to 2 decimal places. Sometimes the rough titration or the trial is done to 1, but I prefer to do everything to 2. So then you're going to work out the volume used on titration 1. That's going to be 13.20. Don't forget the 0 has to all be to 2 decimal places. And then you just work out the difference between all of these one by one. You can quite often get a mark for this in the exam, which should be an easy mark for you to get. Now, to work out the mean titer, you need to identify the concordant results. Concordant results are the results which are within 0.1 of each other. And there's only two here which are within 0.1 of each other. Number 2 and number 3. They're the two concordant results. So to work out the mean, you just do the average, add them together, and we're going to divide by 2, and we come out with 13.0 centimeters cubed. And it says it wants it to 1 decimal place. Not really sure why. Normally it would be to 2 decimal places. Now, you always, well, in the exam, you can get marks for working out the titers. You'll get marks for selecting the concordant results, and you'll get marks for working out the mean titer. They are the easy marks on any kind of tricky titration calculation. So now we know the number of moles of hydrochloric acid, and this table has told us the volume of hydrochloric acid. So the concentration of the HCl is going to be the number of moles, 0.01, divided by 13 divided by 1,000. Don't forget to convert that into decimeters cubed. And you end up with 0.77 moles per decimeter cubed. Don't like that at all. There we go. And that's how you do a slightly tougher titration. Read the question carefully, write down the equation or the chemical equation, write down the equations that you can use in the calculation, draw a quick diagram to help you sort out in your mind what's going on. If something's just changed in volume, just times it by the scale factor and just pick up the easy marks. Because there are hard marks here, but always pick up the easy marks, such as everything that was going on in that table.